Lesson 8.5 continues with logarithms and properties of logarithms. There are three properties that we must have memorized. Very, very important properties. The first two of which are going to require that we have the same base. Here's really what we have happening. If we have two logarithms that are added together with the same base, log base b of m plus log base b of n, this would become log base b of m times n. In other words, if we're adding two logarithms with the same base, we may combine them into one logarithm by multiplying their inside parts. The inside parts, by the way, we can call arguments. Property number 2 is extremely similar, very, very similar. It's just that with the subtraction, we're actually going to write one logarithm, log base b, but this time we will divide the arguments. Log base b of m divided by the log base b of n. Finally, if we have log base b of a raised to the c power, this exponent of c inside we may pull down in front. This becomes c times the log base b of a. So three very, very powerful properties of logarithms. Not only can we begin on the left side and move to the right, we could actually begin on the right side and then move to the left. In fact, we're actually going to begin with that right now. Let's look at example 1. Example 1, we have the log base d of a to the 5th times b to the 2nd. This multiplication of the inside parts should make us look up to property number 1. Property number 1 says that if we have log base b of m times n, we can turn this into the sum of two logarithms. That's what the directions are really asking us to do. Write each expression as a sum, an addition, or difference, a subtraction of logarithms. Express powers as coefficients. Well, property number 1 would allow us to say this is the log base d of a to the 5th plus the log base d of b to the 2nd. Now these powers, however, we can actually bring down in front. So our final answer will be 5 log base d of a plus 2 log base d of b. Let's take a look at example number 2. The natural log of w squared divided by x cubed. I hope you see a very strong resemblance to property number 2. Property number 2 says that we could take this division inside and write this as a subtraction. The natural log of w squared minus the natural log of x cubed. Now from here we can take our powers and actually bring them down in front. 2 natural log of w minus 3 natural log of x. For example number 3, we're coming back to radicals. And actually this is really good review to help us. Before we do any properties of logs, let's remember that a cube root is really a 1/3 power. A 1/3 power. Remember that the index of the root is going to become a fractional power. We see that index showing up in the denominator. Next, do you know what? We could actually use our product rule. 1/3 times 1 is x to that 1/3. Down below, 1/3 times 2 is y to the 2/3. And then what? Well, let's bring this back up here. This now looks so much like property number 2. I'm going to write this as the log base 8 of x to the 1/3 minus the log base 8 of y to the 2/3. One more thing we can do, we can drop down our powers and rewrite this as 1/3 log base 8 of x minus 2/3 log base 8 of y. Okay, well, also keeping in mind that we might have square roots. Well, remember the square root is going to have an understood index of a 2. This becomes the log base 5 of xy raised to the 1/2. And very quickly we could multiply that 1/2 to both of these powers. So this is x to the 1/2 times y to the 1/2. Continuing, we can use property number 1. Property number 1 says that if you're multiplying two logs, if you have a multiplication of two terms inside of a log, you may rewrite that as an addition of two logs. Well, we'll take this 1/2 and drop it down in front. This will become 1/2 log base 5 of x plus 1/2 log base 5 of y. Alright, well, let's take a look at number 5. Using this product rule again, powers to powers we may multiply. This will become log base 6 of c squared. 3 times 2 is a 6. And realize that c squared is being multiplied to d to the 6th. This looks just like property number 1 now. So we may expand this through addition. This would become the log base 6 of c squared plus the log base 6 of d to the 6th. Using that last property, property number 3, we could bring our exponents out in front as coefficients. And wow, look at that. That's as far as we can go. Now, of course, we could also work in reverse. We could say, well, wait a minute. What if we have an addition or subtraction of logs? Could we work that out? The answer is absolutely positively yes. First of all, what you'll do is take any numbers. It's like working these last problems that we just did backwards. Take any coefficients and raise them up as a power. So for number 6, we'll write this as the log of x squared, bring that 2 up, plus log of y to the 5th. Hopefully you remember, if you see a log, that's base 10. But this is now property number 1, and this simply becomes 1 logarithm, and we'll just write that as the log of x squared times y to the 5th. Something I hope you've heard for a very, very long time now, way before you even got to high school, is that you always do things in parentheses first. No exception even right here. We're going to only worry about these parentheses in the beginning. Raise up any exponents as powers. I'll cross my z here, make this log base 7 of z cubed, plus log base 7 of d squared. Continuing to work inside parentheses, an addition of two logs we may write as, plain and simply, a multiplication of those arguments, making that 1 logarithm instead of 2. Finally now, if we were to look at this, we'll say, well, wait, a subtraction of logs, that's property number 2. We can take our 2 logarithms, combine them into 1 by taking our first argument divided by the second one. And that's as far as we go. Let's take a look at number 8. Again, keeping in mind that we always do things in parentheses first. Well, here's what we must do. We can use property number 2 and very simply divide the first argument by the second. But then we'll use property number 3 and say, well, wait a minute, look at that 1/2 out in front. Let's raise that up as an exponent. Now, of course, this would be fine, and we could even stop here. However, we need to remember, we'll be taking a final exam very soon as well, that the 1/2 power is really a square root. Moving on to number 9, we're going to deal with parentheses first yet again. Deal with the exponents. This will become natural log of x to the 4 plus the natural log of y to the 2nd, and we'll leave this as is. Inside the parentheses, let's just group the first 2 terms together. The addition means that we could combine those logs and write them as 1 by multiplying their insides together. Well, now we only have 2 logs and they are being subtracted. What we can do is use property number 2. Property number 2 says that we can very simply divide the arguments. Finally, we can take that 1/3 and we can raise it up as a power. And this, of course, would be raised up as a 1/3 power. But again, something that you need to remember, we studied this before, the 1/3 power is really the cube root. Something we can't lose sight of. On the back, we need to talk about a very important formula called the change of base formula. If I gave you the log base b of a, that would equal the log of any possible base you'd like, we could call it log base c, of the argument a, divided by the log base c of the base. So log base b of a equals log base c of a divided by log base c of b. And of course, very often kids might wonder, well, why on earth would we ever need this? Well, look at number 9. We could bring our calculator up, but we don't have a log base 6 button. We have a log base 10 button for number 7, right next to the number 7, I should say. We have a natural log, which is base e, right next to the 4. But my goodness, you look here, log base 6, we don't have anything like that. This change of base formula says something very wonderful. It says you can write any base that you'd like. Right, this is log base 10 of 18 divided by log base 10 of 6. What we're seeing is this would be typed in as the log of 18, close your parentheses, divide by the log of 6. Notice that log base 10 is log. You'd get 1.61. So it's about 1.61. One very important comment I'd like to make, you could just as well have typed in the natural log of 18, base e, divided by the natural log of 6. Any base will work. That's what that formula is saying. Look, you get exactly the same answer. For number 10, we could write this as log, understood base 10 of 8, divided by the log base 10 of 4. Type this out, log of 8, parentheses, divided by log of 4. Look at that, you get 1.5. Now, like we just said, you could have written this as the natural log of 8 divided by the natural log of 4. Quickly type that in. You will see that you get exactly the same answer. So either use the common log, the base 10 log, or the natural log, which of course is base e, whenever you need to approximate logs that don't have a base of 10 or a base of e. Okay, well, I hope this helps. We're going to just have one more section of Chapter 8 before we get ready for our test. So hope things are working out.